Right. So there's a tremendous amount of technology and complexity inside your OpenStack, but at the end, your business is going to evaluate it on two criteria. First, what is the cost per VM? And there are two hard thresholds that you have to beat. One is whatever the business considers to be the cost per VM for VMware, which is a known quantity. Whatever else you may think about it, it's a known quantity, it's understood, it does what it does, right? And increasingly, the cost per VM from a competitive market of public cloud providers. And as much as IT would love to believe that somehow they're immune from those two things, that something which is open and something which is an in-house project effectively is intrinsically more valuable to the business, ultimately, your arguments across the spectrum of internal customers generally boil down to you want to start out winning these two fights, right? So the first one is cost per VM, and the second is the health of that infrastructure. So what do I mean by the health of the infrastructure? I mean your ability to deliver current OpenStack and an OpenStack that you can scale on demand. So we've seen a lot of OpenStacks that got built. It took time for them to get built. Therefore, by definition, they were sort of on an old version of OpenStack. And then they're stuck there because building it internally, you end up with making a set of choices by a set of people. Those people come and go. Things get complicated. Particularly if there's a lot of integration of custom local facilities from the existing enterprise infrastructure. Being stuck in that way ultimately leads the business to saying that's an unhealthy infrastructure. So you really want to avoid that feeling of being characterized as essentially unhealthy by the business. On the TCO per VM side, you've got a bunch of drivers of that. Number one is the amount of essentially either external consulting or internal R&D associated with that cloud operation. Brutally, your number of VMs gets divided, that cost gets divided by the number of VMs. And in many cases, you're judged in the first sort of year of operations when your number of VMs is at its lowest and your R&D has been at its highest. So this is the sort of tough set of gates that a lot of clouds have struggled to get business support because they didn't have the right numbers going in there. You obviously have things like depreciation and hosting costs. Businesses understand CapEx, though, so that shouldn't be an obstacle. There are some things to learn in terms of how you go about buying hardware and the sort of hardware that you buy. And then there are costs associated with integration, automation, and, of course, the headcount to staff all of that. And managing that, although it's not the sexy technology side of it, ultimately turns out to be key. So the number one thing I'd say is just think very carefully about consulting overhead. If you're going to build a giant cloud that's super special, then it will be worth your while to invest in some particular capabilities. But it's going to take you 2 years to get there. And in the interim, right, you want to be building developer engagement and building a user base effectively without that very significant R&D overhead. So a lot of institutions tend to start by saying we have a lot of ideas about what we want. We need to get people in to essentially consult to us to implement those ideas. Actually, I'd say turn that around. Get a reference cloud up and running as fast as possible. Get user engagement with that, right, while you make those parallel investments. And don't essentially have your developers judging your internal R&D. Have them judging essentially an internal cloud that works quickly and is healthy. And then you've got time to essentially build the engagement. On the hardware front, really the simplest way for us to help you on this is just to give you a current recommendation, and we'll do this for any customer, a current recommendation of the SKU to get from Dell, from HP, from Supermicro, from Quanta. That essentially gives you the best balanced performance per buck. The heart of that really is to avoid any sort of custom tailoring of hardware for different functions. If you walk into a public cloud data center, you will see vast amounts of the same stuff. They don't get into the business of thinking, a rack should have lots of different kinds of equipment in it. And as a result, they're essentially amortizing the cost of any investment they make in the automation of that infrastructure across all these different, all this commodity stuff that they've bought, rather than being stuck with decisions that were made some time ago that essentially forced them into particular architectures. There are real benefits from understanding what the public cloud providers are doing. For example, in networking today, 100 gig, 50 gig, and 100 gig E is getting really cheap, and it's getting cheap because that's what the major public cloud providers are buying. So tapping into that supply chain is enormously valuable. And then there's some other tips and tricks, things like hierarchical storage. Effectively, how do you make disks for your users that appear to be both fast and cheap. Well, the way you do that is you have some very, very fast disks that you use in front of your slow, cheap, rotating tin. And so that way you effectively have fast storage or high IOPS storage at very low cost for the current working set of data effectively. And then containerizing the control plane in your architecture, again, allows you to make the very important argument that every single machine is working for the business, right? You have no machines that are allocated to overhead or control plane. That's especially important when your cloud is first launching, because obviously the ratio of control plane to compute and storage is at its worst in that early stage. So you really want to get that piece right. How you operate at the base layer is really important, and we have been very successful with MAS. We had some questions earlier in the previous session about Ironic versus MAS. I would say that there are now thousands of MAS deployments, more than there are OpenStack deployments. And that's because everybody shares this basic problem of how do I make my data center more automated. One of my favorite users of MAS is Microsoft, who use MAS to essentially beta test Windows by essentially deploying today's build of Windows across hundreds of different kinds of servers. And people like Salesforce who use it for deploying CentOS and Windows at scale. The only Ubuntu in their data center is the Ubuntu that's running MAS. Everything else is CentOS and Windows. Clearly, they have some room for optimization, but at least they're using MAS. And then a lot of people who are coming off the public cloud, effectively, where they've got very large compute estates on the public cloud, realizing that renting compute when you have long-term workloads, maybe doesn't make as much sense as it does when you're a startup. And so they want to be able to create on-premise compute where they have the financial properties of CapEx effectively, and MAS serves that market really well. I would recommend that you try both MAS and Ironic, and then see what works for you. But fundamentally, MAS essentially runs the whole data center for your admins, and then a slice of that goes to OpenStack. And if there's Ironic in the mix there, then if that works for you, that makes sense. In terms of scope, again, it's easy to get lost in OpenStack because there's so much going on, but a huge amount of it is experimental or doomed, right? And it's difficult to explain up front to people why that would be the case, but it is just the case. What you can be sure about is that you'll be judged on your ability to deliver infrastructure on demand. And so really I would limit the scope to that. And then in recent years, Kubernetes has emerged as a really useful abstraction layer across multiple clouds for your app dev users. So the combination of infrastructure on demand and Kubernetes gives you an ability to engage with developers that isn't tied to OpenStack. You can essentially build a developer community that's cloud-centric on VMware, on bare metal, on OpenStack, and on public clouds. So it's a good way to essentially keep your developers in a place where you can engage with them with your cloud infrastructure, while at the same time not having them block on the timelines that you might need to bring your infrastructure up. So let me show you some of this stuff in action the way we would recommend people do it. So this is an OpenStack running on this hardware. For those of you who aren't familiar, this is sort of a half rack. There are 11 Intel microservers in here. One of them is running MAS. The other 10 are sort of switched off and not doing anything until I ask them to be doing something. Here's the MAS console. So you can see that there's a bunch of machines not doing anything over there. Say I wanted to build a Kubernetes on bare metal. So I have already built an OpenStack on bare metal. Let me just go have a look at that. I use an orchestration framework called Juju because it lets me essentially very quickly and easily build OpenStack of different architectures, and I'm just building a reference OpenStack here, so it's super simple, super straightforward. Looking at that in the model-driven approach, there are your OpenStack applications. Juju models things as an application which could have many sort of units, so it's inherently scale-out oriented. And then those units are mapped to machines and containers, which you can see sort of in the lower portion of the status output over there. Let me go. I think that's the model I had for bare metal Kates. and I'm just going to deploy a reference architecture of Kubernetes. So this is basically a standard vanilla current stable release upstream Kubernetes on bare metal. What you will see is I'm pulling in all the operational code. Effectively, Juju is just a way of packaging up Chef or Puppet so that anybody can reuse the same Chef or Puppet, so you don't have everybody forking that stuff and locking themselves into their own changes effectively. So that's going to pull down all of that code. It's going to talk to its cloud, which is the bare metal cloud of MAS. And you'll see some of those machines that are switched off will turn on, the operating systems will get installed, then they'll be handed to the orchestration framework, and the various components of Kubernetes will be deployed. So right now it's still just pulling the ops code down, and as soon as it's done that, it's going to start the actual deploy. Meanwhile, I can, as soon as that's done, I can build exactly the same thing on top of OpenStack, right? So I'm using a model-driven operations framework that's cloud neutral. One cloud is a bare metal cloud, but I can essentially put exactly the same capability on top of OpenStack. I've got a controller running on OpenStack that I'm going to switch to. Now that is running, that is this VM over there, the Juju controller. So that's the orchestration engine essentially. And if I ask that to going to make a new blank canvas effectively, and then I'm going to deploy a slightly different bundle of Kubernetes. It's just a bit more stretched out because I'm on VMs. I don't want to essentially shrink everything down to get the most out of bare metal. I'm on VMs, so I can spread that thing out. And it's going to do exactly the same thing that you saw previously, except now instead of turning on physical machines and deploying Kubernetes there, it's spinning up VMs. In a second, those will start to show up in the Horizon dashboard. So building OpenStack, a reference kind of OpenStack, is really, really simple when you use reference architectures. Building Kubernetes is exactly the same, right? Again, if your focus is just delivering a capability so that developers can engage, you don't get stuck in a lot of complexity and uncertainty and custom development or R&D that's going to drive up your costs. In terms of your trajectory, if you're going to be north of 4,000 nodes within 2 years, then you should be investing right now in headcount for custom architectures and custom operations frameworks. If you aren't certain that you're going to be north of 4,000 nodes within less than 2 years, you're better off effectively focused on managed services for your initial regions. Anything less than 200 nodes, I would attack as a managed service, or reference architectures effectively up to 4,000 nodes, where you're essentially getting trained to operate a reference architecture yourself. The economics of doing it differently when you are less than those scales look really bad relative to VMware or relative to the public cloud. And ultimately, that's where we've seen projects get judged against. You need to think of two parallel tracks. One is the workload track, your internal users, developers, what do they want, where are they going, what capabilities are they interested in, and then your operations track. How are you going to essentially manage and operate your internal infrastructure in a cloud world? But you can segregate those. You can run them in parallel. We've seen some institutions essentially say, wait while we build this fancy cloud. By the time they built that fancy cloud, a ton of the developers that would have worked with them have gone to public cloud and used APIs in the public cloud, which they can't easily get out of. And so now you have a situation where your institution is starting to lock itself into particular public clouds. The approach that I'm encouraging you to pursue essentially says to those developers, use something like Kubernetes for your apps on VMware, bare metal, OpenStack, or any public cloud, as long as you can show that you can deploy that same application on more than 2 of those. Then you know that you're effectively portable and you'll be able to go wherever the business wants you to go, wherever the economics lead the business to want you to be. I've shown you a little bit of Juju. The reason why we think Juju is important is twofold. First, it's model-driven. So what does that mean? It means that you're decoupling the operational logic, how you back up databases, how you checkpoint and manage nodes in the hypervisor and so on, from the architecture. There are good reasons for different institutions to want different architectures of OpenStack, right? But there are no good reasons to fundamentally want to operate a particular component very differently to anybody else, right? There are no good commercial reasons for wanting to be different in how you back up a database. What you really want is you want to be best practice in how you back up the database. And if you can share that logic with other institutions, you're of course making huge cost savings in doing so. You're focusing your attention really on the architecture questions where really there potentially are, there is business value to create. Let me wrap up then. So here is where we see institutions getting to pretty quickly when they follow this path. They have autonomous data centers. In other words, their physical infrastructure is automated. Now, if you see what happens inside a public cloud when racks arrive, the only humans involved are providing that rack with power and network cabling. Everything else is software driven. MAS gets you to the same place effectively. You can buy racks, consume racks, pre-integrated, essentially evaluate all the hardware, test every disk, test every core, every gig of RAM, and then start allocating that to different functions, whether it's software-defined storage or clouds or OpenStack or AI or Windows and CentOS. Whatever it is that you need that hardware to be doing becomes essentially programmable rather than physical effectively. Ubuntu emerges as a common layer. Google is running their public Kubernetes service on Ubuntu, so using Ubuntu for your private Kubernetes service allows you to build applications with a very high level of confidence that they'll run on the Google SaaS of Kubernetes. Microsoft is doing the same. So the Microsoft Azure Container Service, Kubernetes service, is again Ubuntu on Azure. So you're essentially giving yourself the freedom to deploy your Kubernetes applications smoothly on any of those major public clouds or your own private infrastructure. We do see a lot of people doing Kubernetes on bare metal, especially for either low latency or high throughput type workloads. Machine learning is a common sort of push inside the enterprise today, but also in the telco environment, obviously there are a bunch of things that you don't want to introduce any latency around. But Kubernetes sits perfectly well on top of OpenStack. In fact, let's go take a look at that. So there, I essentially created a model of Kubernetes on OpenStack. Here you can see the VMs showing up, and if I switch back here, I should be able to, okay, so there you see those VMs effectively, or is that yep, that's on top of OpenStack. That's Kubernetes getting deployed. What I can do here is just go and say, let's scale it out. That should work. So essentially, I've taken that model and I've mutated it. I've said I don't, I want 4 more VMs providing the Kubernetes worker. That's the thing that actually, runs your workloads. And if we come back to Horizon over here, we'll see those VMs start to spin up effectively and get added to that model. So dynamically, elastically, we're expanding that Kubernetes. Okay, so that's a view from Canonical. Now I'm going to invite Dondi, CEO of BizNetGeo, up to talk about their experience, their products, and their aspirations for OpenStack. Dondi, thank you for joining us.
Thank you, Mark. Okay. Good morning, everyone. My name is Dondi Babadianto. I'm the CEO of BizNetGeo. I think before I begin, I'd like to introduce about the BizNetGeo first. We are a joint venture company between 2 biggest ISP. One is Biznet in Indonesia. Biznet is the biggest ISP other than the state-owned telcos or ISP. IAJ is also the same thing, the biggest ISP in Japan, other than the state-owned telcos. So we have a new product called Neo Cloud, which is based on OpenStack. We built, just like Mark said, it's just a small number of nodes right now because it's just beginning. So we engage with a bootstack. The reasons why we engage with the bootstack, because there are several reasons. One of the main reasons we want to have is stable OpenStack cluster in our environment. Number two, we don't have, even in Indonesia, we don't have enough resources to understand OpenStack, not only from the operation standpoint, but also from the development standpoint. We don't want to deploy OpenStack and then we get pulling our hair off because of the bug and patch. So, and the most important thing, number three, is that we want to focus on selling our services that's based on OpenStack, other than we have to focus on doing the operation and patching. So that's why bootstacks really help us, building our OpenStack and also managing our OpenStack from the operations, technical operations standpoint from day to day. What we do is actually just sales, and if something goes wrong, we just open a ticket and they have SLA how to fix. And the target market for our OpenStack Cloud is actually the developers who work in startups, in small, medium businesses. Yesterday I had a conversation that this guy is the new guy compared to the enterprise who's the old guy. So, the old guy probably using the other operating systems, but the new guy seems all the startups in Indonesia, especially I think about 80% they run on top of Ubuntu servers in several cloud service providers. Why we built the Neo Cloud? Before Neo Cloud, actually, we already had one cloud services called Geo Cloud, which servicing the enterprise or the old guy using VMware Cloud. So why we built another cloud? So there are several things why we built. Number one is that most of the local cloud service provider, these several things actually the perception of the local market about the local cloud service providers. So number one is that the perception is they are still traditional, which is most of the local cloud service provider, they run like a VPS provider per se. All the, when we spun an instance or we, create an instance, they will give a public IP directly to the VMs on the NIC. Number two, it's not really flexible from the payment standpoint because most of the local cloud service provider only charge based on the monthly basis. Number three, that's the highlight over here. The local cloud service, the local market perceive the local cloud service provider as unreliable, so we want to tackle that. And number four is expensive compared to the public global public cloud service provider like Azure, AWS, DigitalOcean, Linode, etc. It's actually more expensive. And number five is not open. So in terms of delivering how to access the cloud, usually the local cloud service in Indonesia, they just give the GUI on the web, and that's how the users can interact only for that. So we want to change all that. So what we do is actually we introduce what we call the flexible billing. So customers can choose between the monthly basis or the hourly basis up to their needs. So 1 month they can choose the reserve, and then the following month they can choose on the hourly basis. And we introduce what we call the multi-region and AZ. Actually, Bootstack built us every region 3 availability zones. We have 2 regions for this deployment. One is in West Java, our area in Indonesia, and one in Jakarta, our capital city. So, and each of this region we have 3 availability zones, like I said earlier. And actually, we are the first one who does this in Indonesia, because most of the, Indonesian cloud service provider, like I said earlier, they only have 1 region, and the worst thing is that, in the region they only built into 1 availability zone, sharing everything across the several racks. So, and we are on the beta right now. We started at the 1st of October. This is the beta registrations, portal.neo.id. And amazingly, we have over 1,000 beta users across the 500 or 600 VMs created. And then, yeah, this Friday we're going to commercial launch, which means we're going to start charging those VMs to our users. So I think that's about it. Thank you very much.
Okay, I think we have time for questions, and it's always interesting to hear what folks are grappling with, what's interesting. And again, you have two completely different perspectives of the market. We're more focused on the private enterprise market. It's great to have folks focus on the public market. Those introduce different stresses and strains. Any questions?
Nice. No question.
I hope that means that it all made sense. Well, not that we're just low on oxygen in the room. All right, if there are no questions, let's wrap up there. Be glad to take them on the side for folks who are shy.